Oh well, at least I tried. So one of the things I'm going to do is show you, or go through parts of a slideshow that they gave as part of their presentation. So it's through climate generation, which is this Will Steger legacy program or institution. And I can give you a little bit of background on that, and I will because I feel like I should. But it says a Will Steger legacy empowers individuals and their communities to engage in solutions to climate change. So they've done this program and are doing this program for emerging leaders, which is young people, educators, the general public. They gave us a packet. This was I was actually given a scholarship, and I know Mrs. Kelch, Don Kelch, from the MFL Merrimack as well, went last season, to the same one, and basically got me to go this year. But we both went on scholarship, which was cool. So they paid for us to go there. So we didn't have to pay for it except for just staying there. No, we didn't pay for that either. Eating. Like one meal. They paid for the rest of the meal. So that was pretty awesome. So through Will Steger, and they talk a little bit about him, and I'll give you a quick synopsis of him. Essentially was a professor in in the Twin Cities, in also one of the Catholic institutions. Maybe that was St. John's. Anybody that knows the Catholic institutions up there can chime in and tell me. But it says, Climate Generation's unique story stems from our founder, Will Steger, a recognized author on the polar regions, and eyewitness to the effects of climate change. This guy is a pretty amazing individual, and I know a little bit more about him because of this institute. So this picture is one of him after a continental and also ethnic, multi-nation, or multinational trek across Antarctica. So he has a lot of firsthand knowledge and experience about the Arctic regions and about climate change, or firsthand knowledge of the climate change that has happened there, or the changes that have happened there. Maybe a better way of putting that. But this one, for example, is a trek that they did, an expedition in 1986, where they went across the continent of Antarctica. So from the peninsula all the way and ended here, which I cannot remember the name of this, but it's one of the southern bases that they use for exploration. But a total of 3,700 miles across Antarctica. So if you can imagine that, I can't really. I mean, cold here is nothing compared to that cold, and that's a long ways. It was also 220 days, so 3/4 of a year spent freezing, basically. But because he loved it, and it's not the first one, so he actually went on several of them. So a pretty amazing individual. That was his major impetus toward, doing this work, and he really spends most of his time still exploring, and has left money toward a legacy, and given that to other individuals to pursue this, and then to use data from NASA and other places. So then this is some examples from Antarctica. This was I'm going to do this because I'm presenting in front of people and I'm freaked out. Can you guys tell me the name of this peninsula in South Antarctica? Oh man, I know what it's here. Sorry, I can't do it right now.
What, Point Barrow?
No.
That's the only thing I can think of.
Yeah, that's okay. So this is it. This is the big thing though. It's the Larsen B ice shelf, and this is one of those kind of canary in the coal mine happenings that most climate people will talk about is that this ice shelf was an example of what is happening to the sea ice, especially the sea ice and the glaciers that are in Antarctica, and then the sea ice that's in the Arctic. So this shows some images, and what I'll tell you is, and I guess I can kind of point to this. If you see these dark images here, what scientists thought they were like water sitting on top of the ice, and they believed that. Antarctic scientists believed that it was just melted ice sitting on top of the ice shelves. This shelf is floating ice. So kind of the important thing to think about floating ice is if you think of a glass of ice with ice cubes in it, and you have water loaded up to the top and ice cubes are in it, ice floats. And if they melt, does the level of the water rise? No. It stays the same. So the advantage to that is that this necessarily doesn't make the spider. Sorry. That doesn't necessarily mean that the sea level will rise if the sea ice is melting. But there are other facts that will happen. There are other factors that can happen. And I'll talk about that in a minute. But I will show you what happened here. And this is one of the things that they did not understand when it happened. Because they didn't realize some things. This happened over a course of a few days. And I have my notes on this computer, so I'm sorry, but I have to look at both. So the number of days that this took, it says within weeks the ice shelf was gone, like pulling a cork out of a bottle, without ice caps or without the floating sea ice. What do you expect happened to the land ice? Oops, I'm going to go back one. What do you think happened to the land mass of glaciers if that sea ice melted and was gone? What do you think it was acting as?
The water would start to melt the ice.
That's one thing.
Well, eroded because they were breaking the waves.
So, well, I'll tell you two things. I guess I'll share two things with you. The dark marks in the ice were actually completely. They were all the way through the ice, so they were crevasses that had melted all the way through the ice. So they were basically seeing the sea through them. So when that ice all melted, what it did was allow, like a cork, right, out of a bottle, it allowed the glaciers on the land to move faster toward the sea. So land ice, since it's on the land, right, moving into the sea and then melting, is that going to do anything to the water levels?
Yes.
So that becomes the issue here. So this ice shelf, this ice shelf is literally the size of about Minnesota, melted in a matter of weeks, or left in a matter of weeks. So that was pretty concerning to a lot of scientists at that time. So then what this becomes for today basically is the questions here. You know, what exactly is climate change? What does that mean? What are the causes of it? What are the impacts of it? What can we do about it, or what can we as nations do about it, or even the world do about it? And then how do you engage in some kind of action that feels somewhat positive, which I think is really important in this and in life in general at the moment. So this idea of fostering hope, pretty big deal right now. It says hope is a verb with its sleeves rolled up. In contrast to optimism or despair, hope requires one actually to do something to improve the world. Authentic hope comes from an imperative to act. So it's a quote from David Orr, but also I think, you know, without action, we have nothing. It's the same, or it goes downhill. One or the other. Not the first individual to say anything like that. In fact, you know, goes back thousands of years. But this is from them, so I'm going to skip it. But well, I won't. I'll use me for an example. So this is their head. Kristen is the head of their organization. But just as me standing up here, as somebody willing to do this, I guess, who am I? I don't know. I guess I'm an educator. I'm not a mom. So, like, if you're looking at this bubble, right where? This one. I'm a parent. I'm an educator. I'm someone incredibly concerned with climate change, have been for many years now. But this is kind of their wheel of what this looks like, right, from the center. So what else am I? It says, what are my resources? My own knowledge, right? My own knowledge base. But then also, like, this Climate Generation Institute gave me some knowledge. I also have a knowledge base based on that out there, right? I spend a lot of time out there, and many of you do, because I know you. So you have a knowledge base that you've drawn on. I have 50 years now of knowledge base as well, right? Having seen the out there. And I will talk about weather and climate change versus the weather yesterday and the weather last week. They're very different things. But, and what I care about, what do I care about? I care about my family. I care about the future of, the planet, honestly. I also care about things like the natural world. I think that we're just a part of that, and I think that that's important to keep in perspective. What communities do I belong to? So when I think about communities, for me, I really think about that huge community out there to start with. Like, I'm just a little part of this huge community. And I really believe that. And I've always tried to teach that as far as, or I guess, I don't even like the word teach. I've always tried to, like, emulate that or to show that to students. Does that make sense? Or to other people. Because I really don't feel like I as a human being, is somehow special on this planet compared to a lilac bush or whatever. But I think that often we feel that way. And then what communities are in my realm? So what things am I involved in? And I think all of us are involved in more than maybe we think about, but we're also involved in micro ones. So, like, do you go to the farmer's market? Do you support that? Do you support local businesses? The community that you live in, your friends, your friend group. Now with things like Facebook, we've kind of microed that. It's kind of tiny, right? Some of us have a tendency to be, almost like this. We put blinders on and we only talk to the people that think just like we think. So maybe that's not all good either. But then, so climate change, science, storage, solutions, and again, that's what I'm going to try to focus on here. Our vision is to build a better future. We must imagine ourselves there. I think that stuff is important. So this green energy idea, again, I'm going to try to stay out of politics early on, but green energy is a big thing, and I think that without people moving it forward, you can't count on politicians to do it. Our current politicians have had a really hard time with this lately, or even accepting any of this. But I don't want to get bogged down in that. This says the 2000 projection. Worldwide, wind capacity will reach 30 gigawatts by 2010. That was what their projections were. And this is from the International Energy Agency. So this was the reality. And this, I think, is hopeful, right? By 2016, that goal was exceeded by a factor of 16 times. That's not negative, right? That's a positive. So, when you look at this stuff, and when I look at climate change science, sometimes I get down, like I get feeling down. But some of this is incredibly positive. So I think that sometimes we need to be less bummed out about it, I guess. But this is Rockport, Missouri, Greensboro, Kansas, Burlington, Vermont, Aspen, Colorado, Columbia, Maryland, Kodiak Island, Alaska, are all U.S. cities using 100% renewable energy. And this data is also from 2016. So I'm not sure what the number is right now because I didn't look it up before this, but that number is going up. And that's pretty phenomenal. And the one that blows my mind, and I don't know exactly where Rockport, Missouri is, but I've been in Missouri quite a bit. and Kansas. So like that surprised me. So that's hopeful as well, right? I think those things are awesome. Again, wind energy stuff. There are over 2.6 million jobs in the U.S. in the solar, wind, and energy efficiency sectors. So this is a giant turbine, or wind, the wings of a giant turbine near Pueblo, Colorado. Again, one of the jobs available on top of one of those turbines. And I think that's pretty crazy. It says wind turbine service technician. It's forecast to be the fastest growing job category, and that was through 2024, and that again is from 2016. So, some pretty positive stuff. Solar industry jobs now outnumber coal mining jobs in the U.S. I'm not positive that this statistic is still valid due to the current attitude toward solar energy, but I assume it's still pretty positive, if that makes sense. Things have changed slightly, but I don't think they've changed enough to completely turn this upside down. So I know that there are many jobs still available. So this is Power Right American Jobs, solar, just solar. This is again in 2016. So I'm pretty aware of the fact that data today changes pretty rapidly, especially in these kinds of areas. But if you look at this, 2010, there are 93,502 solar jobs in that year. And then by 2016, there are 260,077 jobs. That's pretty phenomenal. It says that number of solar workers is a 25% increase over the previous year. So solar jobs have increased at least 20% each year for the past 4 years. 1 in 50 new U.S. jobs were in the solar industry. That's pretty amazing. Again, positive news, right? At least, in my mind. Although I just came from over by Highland where they have signs up against the giant solar installation. So it's not all roses, but definitely this stuff is positive on the whole. This slide says $26 per hour is the median wage for solar installers. I think that's more than I make as a teacher. I'm pretty certain of it. Solar is increasingly diverse. 28% women, 17% Latino or Hispanic, 7% African American. Surpassing the jobs in the fossil fuels. So, again, the numbers there, wide-ranging career opportunities, installation, manufacturing, all that stuff. So just showing, I guess, that there are many opportunities. The top 20 solar job states are obviously several of them on the coast. Texas, think about it though. Like, what's one of the top fossil fuel producing states? Texas. Colorado's right up there too, but it's also yellow. So those states are moving into these realms, which is a net positive. I think as well. Illinois, Iowa, Wisconsin are not yellow, unfortunately right now, but Minnesota invests in clean energy, it says. This is from, Climate Generation is from Minnesota, so some of this is going to be Minnesota biased, but we're not too far from there. As of March 2017, they had 447 megawatts of solar power. So that was up, again, from 37 megawatts in 2015. So in 2 years, they'd upped it a lot, 200 megawatts. So it says 1 megawatt equals 1 million watts. It's enough electricity for 140 homes. That's some pretty impressive numbers again. I hope this one loads. There, okay, sorry. So what world do you want to live in? What is your vision for the future? What legacy do you want to leave? One of the things, and this is an image that I showed in my environmental studies class. I left the school at NFL Marmax, and I keep saying that I keep thinking I'm still there, and I'm not. So I keep saying it in the present tense. So when I taught environmental studies there, this is one of the images that I always showed. to students because I think it's an incredibly powerful one. So what I always ask them, and I'm gonna ask you guys because this is what I do. Why would this be a big deal? Why would this have been a big deal in 1973? I think it was. I think that's right. 1971. 1972. I was right.
Nobody'd ever seen a picture of the earth like that.
Nobody had ever seen a picture of the Earth like that. That's totally true. Why did that matter? Why does this image matter? Or why did it matter? What's important about that? Or what things can you say about this image? What comes to your mind?
We're very insignificant.
Why?
We don't take up much space.
You don't take up much space. Do you see any people
There's
there?
a lot of blue there.
Do you see any people there? So I let kids talk about this for quite a while, and I would talk about it for quite a while. Why this image at that time? The first time we had ever seen the entirety of the planet Earth from space. Why this was so significant. And it literally started the environmental movement. Because for the first time, humans were able to see the Earth as what it really is, a tiny little speck. So I can go into Carl Sagan too. That stuff's amazing. We are literally a pale blue dot or speck, a mote of dust. Horton Hears a Who always comes to mind. So it's pretty amazing. So it did start that. So like this little tiny blue dot that we live on is pretty precious. And that's a picture of what? Yeah, our atmosphere is what I'm going for. But yeah, it's sunrise. But it's a picture of our atmosphere. So any guesses as to how thick basically our atmosphere is? Roughly.
Skin on an apple.
Yeah, there's all kinds of analogies. But do you know how thick it actually is? Yeah, so like the entirety of it is roughly 60 miles. That's all of it. But most of what we live in is within about 6 to 8 miles. Not very far. Not far at all. And most of what we even include as our atmosphere is roughly 20 miles. So incredibly thin, like the distance from here to my home. Pretty thin. So again, a perspective that, it's pretty precious, something that you need to take care of. So greenhouse gases, the effect of, the effect of the sun on our climate, and the greenhouse effect is really what this is. So what happens is our atmosphere traps some of the solar radiation, some of the photons are trapped by our atmosphere. That's shown in the red, right? And bounces off the atmosphere and stays in. And some bounces off back into space. That's a good thing. Venus, temperature during the day there's about 400 some degrees Fahrenheit, not real livable. Here, it's pretty pleasant for the most part, even when it's warm. This is the global surface temperature, the departure from average. So over quite a wide range of years. But this shows from 1880 to 2016. So this is one of the kind of iconic images as far as people that talk about climate change go. So in our time of recording data about temperature, the climate, etc., these are the surface temperatures and the departure from average over that period of time. What do you notice about this?
Well, it looks like it's flip-flop. Absolutely flip-flop.
Yeah. And the general trend is headed in one direction. Up and up. So, this side of it, when you look at this is degrees Celsius. And this is 1 degree. So that seems like very little, but that's globally speaking. And I've heard estimates that 4 degrees Celsius, if we changed 4 degrees Celsius warmer, that would be essentially the highest that we could possibly tolerate globally. like we would be pushing into the next extinction because the ice caps would melt, sea level would rise to beyond what we've ever seen. So that 1 degree change is a pretty big deal. It doesn't seem like it sometimes when you just see 1 degree, but it is. It says what factors have caused this rise in global temperature over the last century. This shows the natural greenhouse effect. It says more heat escapes into space. Solar radiation comes in, greenhouse gases. You know, this idea, even most of the kids when I talk to them have some idea of this. So you have carbon monoxide is a big one. Methane is another big one. And then this says human enhanced greenhouse effect. So less heat escapes. There's more CO2, more nitrous oxide, and more methane. So that heat is re-radiated and held within the Earth's atmosphere. So basically the two things are somewhat in opposition, and the one is not as good as the other. This is the biggest sources of greenhouse gases. Shows quite a few things. Some things that people don't think about, like the thawing permafrost. So some of these things, like when you see them, air transportation. How many of you have flown in a plane? So do you think that number is going up? It's going up significantly. So like when you think about it, and I like to fly now, but I had never flown until I was 40, almost. I don't even know. So I was older by the time I flew. So like some of this other stuff too, though, fertilization, land transportation, landfills, forest burning. What's happening right now in half of the West? It seems like, right? And this isn't planned burns. This is burning forests that's either by accident or for clearing land. Industrial ag, so CAFOs and big ag, coal plants, and coal mining. So and then industrial processes. So there's all kinds of stuff that sometimes we think about, sometimes we don't. All kinds of things contribute. Then this says the total U.S. greenhouse gas emissions by economic sector. So when you look at this one, sometimes this sector gets blamed a lot. Ag. And it's not that they're not important or not that they're not contributing a great deal, but that's 9%. Transportation is 26%. So that's every form of transportation, however. So vehicular, the tugs out here, trains, planes, and whatever other forms, hoverboards, I'm not sure. I think it's something else.
I know this isn't your slide. Do you know how are they differentiating commercial and residential ones versus electricity?
What I will do is see if I have anything on this one to tell you. This is, it doesn't tell me where it's from. So, but what industrial and commercial residential, what I'm assuming is commercial residential would be like smaller time stuff, and I would assume industry would be bigger industry.
Well, no, I was meaning commercial residential versus electricity.
Oh, I'm sorry.
All of our electricity goes to commercial and residential use.
Yeah.
Because we don't.
I'm assuming that's generation of electricity. Yeah, I think that's generation.
Versus commercial and residential housing.
Use of energy.
It's economic sectors.
I agree. This one is not the greatest. Like,
commercial and residential could be, like your lawnmowers.
Yes.
Contributor.
But
that wouldn't fall under any other category.
I don't know. Like that, unfortunately. It could be all kinds of stuff. I agree. This isn't the greatest slide. I don't think. At least that's what I think. So then this goes into the benefits. So benefits, because there are benefits. I've benefited from fossil fuels. So benefits of coal. This is talking about why is coal of benefit to any of it? It says material in steel, it's cheap electricity. Steel is a key construction material, electric lights, all that stuff are indispensable to our way of life. Like, if you imagine trying to live without that stuff, that would be difficult. But then natural gas, second to coal in generating electricity. In the United States, gas is widely used for heating and cooking. So, like, we cook with gas at my house, and heat with it at times. So the idea of oil, it's used for heating, it's used for lubrication, it's used for materials, it's used for transportation. So at the moment, then you have to also go into plastics. So like plastics for us right now, and other synthetic materials. So like if you wear anything that's synthetic, which means yoga pants and everything else, you know. So like all that kind of stuff, or like a lot of our shirt, like this shirt, I'm guessing is not 100% cotton. It's probably half and half. So all those things are made also with oil. So it's burned as fuels, you know, it's used for all kinds of things. So there are definite benefits. But then, you know, this is actually showing, again, this is, some people think they're nuclear, but that's a coal-fired plant. So this is a way of bringing this to Minnesota to localize it, but this is true of any state. So this was meant to make it more local. So neighborhood A, it says a tale of two Minneapolis neighborhoods. These were real neighborhoods, but it says these disparities did not arise by accident, but through years of decision making and land use planning that results in such high disparities in the health of communities like this. So I gotta catch up on here. And they don't have any. Okay. So this shows neighborhood A, the population density is 11 people per acre. B, 3 people per acre. The percent of color, 75 in the more densely populated, 10% in the less densely populated. House value, 266, 3.8% existing tree canopy, so very low number of trees, 42%. Again, as carbon sinks as well. So trees act in many ways as a positive. So this is going into a little bit of the disparity that is a reality in our world. Federal subsidies have favored fossil fuels. So again, I'm going to try to avoid the politics of this at the moment because everybody in this room understands that this is actually getting worse at the moment. So, but this is where they're at as of 2010, dollars in the billions. So in 2010, biofuels, the subsidies were about 32.34%, or sorry, $32.34 billion. Renewables, 5.93, so a sliver of that. Oil and gas subsidies. So when we talk, like, the thing that I will say out loud is that when we talk about welfare, when we talk about corporate welfare, we talk about social programs, I'm not sure how this differs, except for this is going to companies to produce energy for us that we then pay for. So I'm not sure how this makes sense, or why this makes sense. I'm not sure of that. So we're giving, as a country, that amount of money to oil and gas companies, that amount of money to nuclear companies, and then that sliver to biofuels, which includes, as far as I'm aware, biofuels that include ethanol. And then renewables, solar, wind, and any other renewable. And there are a few others. So that's where we were at fairly recently. This then gets into a little bit of politics. I might kind of skim through this pretty fast, but this says, again, as cause of climate or climate change, money that fossil fuel industries spend on lobbying. So this is looking at politics, right, as a part of climate change and climate change politics, basically. So the Cruz, Ted Cruz in his Senate race in 2015, 2016, 1 million, I just did that wrong, sorry, $247,957, right? Hillary Clinton, not too far behind. So, when you look at this, really, is it a partisan, issue or not? Or is it our issue as a people? I think sometimes that gets kind of muddy. I don't know that this is a partisan issue. It's more of a human issue. And I think that that's something that's worth looking at. So certainly not, only Republicans or only conservatives are receiving money from these big energy companies. Again, humans are causing climate change. Not refuted at this point. CO2 is being released into the atmosphere faster than any time in at least the last 66 million years. So this data comes from ice cores drilled in Antarctica. So they could go back 66 million years in the ice cores and see the levels of CO2. And the major contributor of CO2 at this point in time are humans. So since humans weren't around 66 million years ago, humans were around 66 million years ago. However, I should have said it this way. Humans were not creating lots of CO2 66 million years ago. Since there were, I'm trying to guess at how many, there probably were, I don't even know. I have no idea. 200 million years ago is roughly when Homo sapiens came about. So since that,
200 million or 200,000?
200,000 years ago. Thank you. We weren't around, did you just?
No.
We weren't around 66 million years ago. You just totally blew my.
So,
thank you for correcting me.
So for the climate change deniers,
Yes.
who are like, well, the Earth has done this before. Yes, but humans have never been
Yes,
there.
exactly. So 66 million years ago, we were not here yet. 200,000 years ago, we were. So thank you, for clarifying. I get my millions, billions, and even thousands screwed up sometimes. So this is the, so when I don't even know how many years ago this all started for me, but this just totally reminds me of an inconvenient interest, and Al Gore. So because Al Gore studied climate, talked about climate with one of his professors, and I can't give you all of the information because I don't have any kind of like memory that does that. But what this is data that was collected by a professor out of one of the universities on the West Coast. I don't remember which one. I want to say it was Berkeley, I'm not even sure. But they collected it over a large number of years, and they collected it using weather balloons. So it was 1959 or 58 that they started collecting this. And the up and down, I'll explain in just a minute, but these are parts per million of carbon dioxide. So what do you notice about this graph? It's doing what? Rising. Steadily rising since 1958. So did the Industrial Revolution start here? No. But they started gathering this data then. Does that make some sense? And it hasn't done anything except for steadily rise, right? And if you notice where we're at, 407 parts per million, 2016, there's a group called 350.org, and I'll actually share a document that I made up that's really quick, or a short one. It's a Google Doc if you want it, that links to a lot of different organizations. But 350.org was started because of a scientist in the 2007-ish who said that if we got to the point, so if you look at 2007 and go over, he said if we hit 350 parts per million, that would be our tipping point. That beyond that, we probably couldn't recover. So where are we? That's not as hopeful, right? Again, like it's just that part of it. But that doesn't mean that we're doomed. what it does mean is that we're already past what one major climate scientist said was too much carbon dioxide in our atmosphere. So, not necessarily a positive. And there's more information at 350.org if you ever want to check that out. This is the global temperature and carbon dioxide. So, like, if you look at this is carbon dioxide concentration and the global temperature. What do you notice about those two graph lines? Do they have any relationship? Yeah. So, I guess to me this is one of those graphs that it points out the fact that, and scientists have known for years that CO2 increases the temperature of a planet, right? Because we've known that Venus has a concentration of CO2 that's way greater than ours, which is where we got the idea of greenhouse gas or the greenhouse effect from. That's why the temperature of the planet is so high on Venus. So this kind of shows that and where we're heading right now. So I'm going to go backwards once. This is kind of interesting to me. Why does this go up and down? Does anybody in here know?
Is it seasonal?
It is seasonal. You know the why?
This is in Hawaii?
Nope.
Where's
It was near. This is data? Yes, it is. In Hawaii. Sorry. Which is pretty equatorial. But still, what happens to our entire planet's atmosphere? Well, I'll just kind of explain it. So what our planet does is every season, even though this is equatorial, right? The planet as a whole breathes in and out, basically. So it's like the respiration of a leaf. So because there's more green in the summer in the northern hemisphere, which this is barely in, and even they said even in the tropics, it still breathes in and out. So it's like the planet breathing in and out. So our carbon dioxide level actually goes up and down a little every single year. But obviously the trend line is still moving up on the whole. So that's always interested me, and they had to figure it out when they noticed it to begin with, because it was like, why does it go up and down? Yeah, so it's like the planet breathing in and out.
So is it like all the leaf vegetation that grows during the summer is mostly carbon based, so it takes a bunch of carbon in?
And the ocean.
Okay, the ocean. So because it's all grows in the ocean.
Mostly the ocean. Yeah. Okay. And so, this gets a little bit to the ocean, and I can talk about the ocean a little bit more, but the ocean is the biggest factor. And I hope this will play. It did earlier, so we'll give it a second. There we go. This is a kind of a how do you know.
Snow.
I might let it load for a second.
Snow. Snow is added to the top, turns into ice and ice.
Oh, I'm sorry.
Snow is added to the top, turns into ice and ice.
I don't even know why this is doing it. It's goofy. So how's everybody's summer going?
Lower carbon in the air.
Is that on Wi-Fi?
Yeah, it's low. Ever seen a beaver on a stick? We have one. Just saying.
Keep it clean.
That's still one of my favorites. Are there any children? I won't go any farther with that. Sorry. Here we go, what's right now?
Snow is added to the top, turns into ice, and ice core scientists can drill holes through the ice sheets and pull out a core and examine not only the ice, but also bubbles of ancient air that are trapped in the ice.
Still loading.
By looking at the chemistry of the ice, we can learn about past temperature, and by looking at the air, we can actually measure carbon dioxide. One of the things
Oh, I have
is
a hard
added
time.
to the top,
Sorry.
turns into ice, and ice core scientists can drill holes through the ice sheets and pull out a core and examine not only the ice, but also bubbles of ancient air that are trapped in the ice. By looking at the chemistry of the ice, we can learn about past temperature, and by looking at the air, we can actually measure the carbon dioxide content. And one of the things that we learn is that past temperature and carbon dioxide vary together.
Okay, here's one of those things they gotta do. So they're going, what was that one?
800,000.
800,000 years ago. So this is one of those things that I always loved. 800,000 years ago, these are every 100,000 years. So they're doing carbon dioxide and temperature. So what do you notice about those lines? Are they following along fairly similarly? Or they're
Changes a lot.
yeah, but they're both following each other pretty closely. Does that make sense? And they continue to do that. But this is over hundreds of thousands. Each gap is 100,000 years.
They go up together, they go down together. And over the last 800,000 years or so, atmospheric carbon dioxide was never higher than about 280 parts per million. Until we started adding carbon dioxide to the atmosphere. And now it's about 390 parts per million. That's about 40% higher than it was.
Oh, come on.
Carbon dioxide was only varying for natural reasons. Now we're headed for 500 parts per million or more.
That pace is
Sorry, I might just move forward. Now I'm back to 1, so I might have to go to this. So what I can tell you is that, and I'll try to, I hope they have the graph in here that I can show it. That shows that, but everybody in here understands exponents, right? Or maybe. I'll show you what exponential growth looks like in a second. I'm having technical difficulties. I don't have a whiteboard. So, the thing is that where they kind of ended was the 1800s. What happened in the early 1800s? Industrial Revolution. So we started to use coal to power things. Burn fossil fuels eventually. All of those things started to happen, and they happened on a very, very, very rapid rate, or at a very rapid rate. So, people like Henry Ford and the iron or the steel barons and the railroad barons and all the things that were happening in the 1800s started to happen. So the Industrial Revolution happened pretty rapidly when you think about it, as far as when you're looking at 800,000 years, right? So you get from 800,000 years to 1800, and suddenly things started to change. And I will show you once, and now I have to go backwards because I just jumped way too many. But I'll show you a little bit of what that looks like, which is what they were trying to get to there. Okay. I don't know what that means.
just tell us this stuff.
Yeah.
We know it.
So it meant exponential growth as far as, well, exponential changes as far as the atmospheric as well as oceanic temperatures, and and accompanied by the level of CO2 in the atmosphere. So those things essentially were coupled, and they had figured that out before then, but it's been over the last, so essentially they have data now from the early, so there we are. I'm just going to skip this second. So basically what they have is, how they know it says the fingerprints of changes in the sun's output, input, human caused changes in greenhouse gases. I don't know what that is either now. Quit doing this to me.
Wonderful technology.
Yeah, it's cool except one doesn't work. So what it means is that those things have been coupled. So our atmosphere is heating up at an exponential rate, and the level of CO2 in our atmosphere is also rising at an exponential rate. So when you look at it over the last 800,000 years, from 1800 honestly until 2016 is which this data comes from. Those things have changed dramatically. So we've gone from no more than about 280 parts per million of CO2 all the way up to right now where we're at actually just past 420 parts per million was the last time I checked. So that's an incredible increase, almost double. So in the last 800 years. So kind of like Roger said, the thing that has changed in that time is that humans have evolved to the point of the Industrial Revolution. And because of that, have increased the amount of CO2 that we put in there. We did that. So, and that's science, if that makes sense. Science shows that. So the other changes have stayed pretty steady. And that graph of 800,000 years shows the ups and downs. Does that make some sense? There are many, many periods of glaciation within that 800,000 years. In fact, more than I'm aware of. I know there are at least 4, and those 4 didn't happen in that period of time because we were literally at the equator within 160,000 years ago.
About
480.
490 million years ago.
Okay, sorry, yes. See, there I go with my 1,009. So, we were at that time starting to move toward where we are now, but we would have still been farther south than we are now. So, the last 4 glaciations happened in the last 200,000 years. Is that correct?
Yeah, it depends on who you talk to. I just use a rule of thumb. Within the last 2 billion years, this whole current cycle started. There's been a lot of peaks and valleys between glacial, interglacial stations.
Yeah.
And where we're at, we're supposed to be the driftless area. We're actually on the edge of one of the earlier glacial ice sheets, right where we're at. That's why this valley, Mississippi Valley, is where it's at today. And it's a long story, but you and me have found glacial erratic basalt and granite in places where it isn't supposed to be,
Where it's
like
not
right
so.
around here, up on the hills, like hundreds of feet above the valley. So we know, those weren't brought in by high water; they were brought in by ice sheet.
Correct. So proving that there was some glacial activity in the Driftless area.
Yeah.
Or region.
But not recent.
But not recent. Not recent. Not recent in human years. So I'm going to see if I can get back there quick and see if this will work. I'm sorry. I'm going to skip that one out because I'm afraid of it. So So this one I'm not gonna do a whole lot with because it's talking about changes in the sun, and in the stratosphere and our troposphere. But this one I'll see if it will work. If not, let's go on. So again, we're gonna look at kind of human time. Because Earth time is interesting, and the 600,000 years of ice cores that we can look at tell us a lot. But then also the time that we're living in, we're seeing two things, I believe. We're seeing weather and we're seeing climate change. And the indicators of climate change were like the 1958 to 2016 increase in global CO2 levels and the increase in the average temperature on the planet. So things like that to me indicate climate change. But these things also, so this is an example of the permafrost. This is an Inuit man. This is an example of what's happening to the permafrost in the Arctic. So the permafrost is melting and people's houses are literally falling into the ground or falling apart because the permafrost is melting. Those kinds of things obviously haven't happened in a very, 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 very long time that those people remember. So if you think about the land bridge concept, which is being rethought a little bit, but that supposedly happened in human time a very long time ago. Does that make sense? So in all of that time, there's no record of this ever happening. The permafrost melting to that point in those areas. So this says 97% of climate scientists agree. I looked up a NASA site this morning. It also said 97% or more of all leading science papers, peer-reviewed papers, all agree that climate change is human created and is happening. It says here 13,950 peer-reviewed climate change articles between 1991 and 2012 agreed with it, and 24 rejected global warming. So are there people who deny or disagree with it? Yes, they exist. There are not many, and I'm not gonna spend time with that because that to me doesn't make much sense to spend a lot of time on that. 97% of climate scientists agree. They say that this bridge is going to collapse. 3% say not to worry. You're gonna keep driving on it. I know people that would, but one might be me. Just one more time, you know. But I think in general it's a fact. And my daughter knows that that's a fact. So where does the carbon go? Carbon cycle, really quick. I don't know how many people in here know this, but the carbon cycle is kind of cool. If you don't know anything about it, I'm sorry I thought I had a different view on there, but I don't. I'll show you so it's better. So maybe not. Maybe not. We'll just deal with it. So carbon cycle, there's all kinds of things involved in it, I guess, and the things that are normal is dead things die, they become waste. Some of that goes into fossil fuels, so some of that carbon goes into the earth. Some of it goes is respired by roots. All that stuff from emissions, the CO2 from emissions is going up. Plants respire or they breathe out, basically. When they breathe out carbon dioxide. That goes into the atmosphere and will spark. Honestly, there's a ton of methane that goes up. That's actually a huge thing. There's actually a theory that dinosaur farts were part of the reason that they went extinct. Because yes. So, and it's an interesting concept because the methane in the atmosphere increased to the point where the earth heated and they couldn't live. So, all of that stuff. But then you have, again, decay, which takes carbon back into the earth. Photosynthesis is an incredible process, but it does take some of that carbon and turns it into sugars and into life, basically, that we use and we live off of. So that's real simplified. The sun brings, photosynthesis about, or helps to create photosynthesis. I don't know why I can't make this full screen again, but I'm sorry. No, I can't even make it go forward. It says 10 indicators of a warming world. So air temperature near the surface of the troposphere is increasing. Water vapor then increases because as the atmosphere heats, it draws up more vapor. And Phil's a great guy to talk to you about this. Temperatures over the oceans actually increase, which again draws more water into the atmosphere. The sea surface temperature itself is increasing. The sea level is rising. The ocean heat content, that heat that's held within the ocean, or the temperature of the ocean, is increasing. The sea ice is decreasing. So the amount of sea ice is decreasing. Temperature over land is increasing. The glaciers and ice sheets are decreasing, and if you want to see images of that again, this Stinger actually also crosses Greenland from the top to the bottom. Greenland is an incredible place to look. Patagonia is the images from those places are phenomenal. So when you see them and you see the changes, even Switzerland, or Glacier, what will soon formerly be known as Glacier National Park, literally has virtually no glaciers left. And some of you have been there, I'm sure. They're receding incredibly rapidly. So snow cover again, decreasing. So the thing about sea ice decreasing, and some of you may know this, and I don't remember all these slides in the order of them, and I don't care because it doesn't matter. So sea ice decreases. If sea ice decreases, what do you think reflects more heat, ice or water? Ice. Why? What color is it? It's white. So just that, right? Just the color of ice, it reflects more heat. What's the color of water? Is it darker? So if you're wearing a dark shirt, do you feel warmer from the sun's rays? So sea ice helps to reflect more heat. Once that ice melts, it's like 9 times faster that the water warms up. So once that sea ice is gone, the water temperature rises way faster. I'm not sure on that exact number. So like you can quote me on it, but I'm probably wrong. It might be 5 times. All I know is it's way faster. So once that sea ice is gone, the water temperature rises. So what happens? The rest of the sea ice melts faster. And then the glaciers on the land start to move into the sea. So it's a cycle that is really hard to stop. The Northwest Passage that used to be, a dream of sailors, last summer it was a reality. The summer before it was a reality. So the last 2 summers, the Arctic has actually been open to navigate from one side, across the polar region to the other side. There are already companies buying the rights to the seafloor in the Arctic. Why? Because they'll soon be able to drill it. That's also something to think about. This global temperature change, I don't totally understand this graph, so if somebody can explain it to me, go for it. And my notes on this, I don't really get, so sorry, I don't really know what it means. I'm just being honest. It's one of those that I don't really get. This one says the hottest days. This thing blows my mind, and this only goes to 2016. So 2017 and 2018 are not on here. And guess where they fall? On here. 2018 actually would be the top. So the hottest year ever measured, the hottest year ever measured, 16 of the 17 hottest years on record have occurred since the year 2001. So if nothing else, if you look at the dates there, they're all in the 2000s except for 1998, which is when Ale was born. So, but I mean, that's the lifetime of my child. every year on there is within her lifetime. And now her year was bumped off. It's now all in the 2000s. It's 2017 and 2018. 2018, unless it changes drastically, will be on there and take place at 2. So we'll have 2017 and 2018. So, all 17 of the last 17 years have been the hottest ever recorded. Again, that's weather, but it's also data, right? And what's that data doing? Does that make sense? So that indication is what I'm interested in. And that to me is science. So that's important. Weather versus climate. So weather can be your mood, right? Weather can also be what do you decide to wear. It can affect your mood. It can affect what you wear. It can also be just considered what's happening outside right now or what's happening in your area. The climate, it can be looked at, I guess, as your personality or what you actually have in your closet. They're trying to do analogies, which I don't know if these are the greatest. But to me, climate is the overall general thing, right? Like the way that you maybe are versus your mood that day, the real you. So like this says weather and climate change. Weather, 1 3-inch plus rainfall is weather. Climate change is doubling the 3-inch rainfall frequency in Minnesota every 7 to 3.5 years. So it used to be every 7 years. Now it's every 3.5 years. And I'm sure after this year, that number probably went up again. I just was through central southern Minnesota, and there are literally still lakes within cornfields there. It's unbelievable how that's changed, and I've noticed that. So that's a difference, and we all know that the Cedar River and the Des Moines River have flooded at least 3 times in the last 10 years, significantly.
And Kickapoo had 2 500-year floods within, 11 months?
Yes.
And 2 days before Christmas Day in 2016, they had 7 1/4 inches of rain, not snow, but rain, along in the Gaines Mills area. I mean, that is unheard of.
Yeah. So when they say those things like, it's a 100-year flood, and it's a 500-year flood or a 100-year rainfall, but you hear that 3 times in 5 years. Well, that seems to be an indicator to me of something awry too. Again, I can't say myself with those 3 data points that is because of climate change. But when you look at the data over, again, even from 1958 on, or from 600 million years ago, or even even the last 17 years or 19 years. But when you look at data points over time, that's climate, and it is changing, and it is warming up, and that's important to acknowledge. So again, weather versus climate, a little bit about it. 2016 was the 40th consecutive year with the global temperature above the 20th century average. So 2016 was the 40th consecutive year in the 20th century, or above the average temperature of the 20th century. So consecutive, 40th consecutive. So again, that's consistency, right? This is again Minnesota. I wish I could make this full screen because it's hard to see. Yeah, this one. This one? I don't know what I did last time. Let's do this. This isn't supposed to be a slideshow, but it's not. Maybe if I click this one, it'll go away. I quit. So here, I'll try this. Alright, so graphs, again, says winter average temperature is in red, and the smooth trend over time, and this is a 43 linear year trend. So this is Minnesota warming trend from 1970 to 2011. So again, this is temperature in degrees Fahrenheit. So this is 18-ish over to 2010, 2011. So again, maybe it doesn't seem incredibly significant, but that's 11 degrees Fahrenheit to 15 degrees Fahrenheit, and that's a change of that. So this is, again, the first fastest warming state right now is Minnesota. So that's a big deal to people who live in Minnesota. This is showing temperature change since 1970 in degrees Fahrenheit per decade. And I'm going to try this one. Sorry. So if you look at this, some of these states are warming pretty fast. Some faster than others. And that's part of what they talk about with climate change, that it's not something that's going to be straight across the board. But I also can talk about political things in other countries. And if you think about them, like think about the country South Sudan, the newest country on the planet. Where is it? Exactly, it's a sub-Saharan country. The reason they're fighting there is water. Why are they fighting over water there? Because they don't have enough. Why do they not have enough? What's happened there over this same period of time? The temperatures have gone up and their water's gone away, basically. So water has become an incredibly important commodity now because of this, basically, the fact that temperatures are increasing. And also energy use is increasing. So we can talk about that a little bit too. This is why I was mentioning that. It says at least 2,330 people died in 2015 heat wave in India. That's India. Why India? What do they not have in India that we have in the United States? Air conditioning. At least not to the degree that we have it. So they also don't have the access to other things like, even maybe cold water. Certainly not clean cold water. It says in the future, the climate in large parts of the Middle East, North Africa, could render some regions uninhabitable, which will surely contribute to the pressure to migrate. Again, this plays directly to me into what's happened in the Mediterranean Sea in the last 5 years around the Mediterranean Sea. That's been happening. That's really happening. So, and then now we're talking about the instabilities in Southeast Asia and in the United States. So one thing I know about it, and it hasn't really hit the news much, but in Louisiana, in southern Louisiana, in the bayous, there's a Native American tribe, and I can't even name the tribe because this just doesn't do that anymore. I can't keep those things in there. Some of it has to go out. But their reservation lies in the bayou. Their reservation is now virtually underwater because of sea level rise. So they're having to be, these are also the individuals who the Trail of Tears is about. These are the people who travel the Trail of Tears to that area to be relocated. Now they're having to be relocated again because of climate change. So this is happening right now. And areas like Bangladesh, India, some of the poorest places on the planet, like Delhi, are going to be the most affected because they're not able to cope with it. They're also on the coast. So incredibly high populations that are going to be migrating, are going to have to migrate. This says more snowfall records recently. So this is 43% of records set since 1980. So from 1872 to 1979 and then the earlier ones. So what this is showing is these were records of more snowfall versus less snowfall. So it's pretty different. But if you see the blue, they had more snowfall up to 1979, and then the rest of it is less than average. So Colorado, I know, this area of Colorado and this area of Colorado are both. What's that?
Wells County, we're just out there.
Yeah, is skiing country. You bet. So lots of changes in those areas. So in the amount of snowfall. So they're also, again, that's becomes economic, right? That becomes an economic issue. So Vail, the other town that they ski in all the time, I can't even remember it. What is it?
Breckenridge.
Breckenridge. Thank you. Those areas have, their snowfall amounts have changed dramatically over the last even 10 years now. One guy I heard, and this wasn't even connected to this at all, I was just reading about it. He was saying that last year in Vail or Breckenridge, he didn't even ski because he said there was no snow, virtually no snow. He said, and I don't know which town he was in, but it was amazing to hear that change because they get snow like we've never seen.
And all of their pines are dying.
Yes, yeah, and that's a little bit different, but and I could talk about that too a little bit, but that's somewhat, they say, related to this as well. So this is leaves emerging earlier. So some of you have noticed this in your own backyards. I have, like the fact that so phenology is what this is about. So like looking at plants and what they do and when they're budding, when they get their first flowers, when they first leave out, that stuff. People do this, and people have been collecting a lot. This is citizen science. People collecting data on this over a large number of years. This is the 30-year average. And it says, where's the heat going? 93% extra heat goes into the ocean. So again, the oceans are warming faster than the air. Warmer air can hold a lot more water vapor. So if you're a cloud watcher, the clouds have been more interesting lately, I think. But also hurricanes have been a bigger deal over the last few years as well. So this is hurricanes and climate change. What we know, warmer water equals more fuel, heavier rains, and higher storm surges. So I have friends that live in Florida. If you have friends that live in Florida, or if you're thinking of retiring to Florida, you might want to rethink the thoughts of retiring to Florida. And you might want to go visit your friends pretty soon. Because the images of Miami lately, last summer in Miami, yeah, they had feet of water, 2.5 feet of water on their main roads in Miami.
On a clear day.
On a clear day. Because of storm surge and high tide. It's pretty impressive stuff. So this is more extreme weather again. That trend line is going up. It's up and down, but it's going up. So the numbers from 18 to 22 in 2017. That may not seem like a lot, but the trend line is up, and it does alter. But again, it's a trend line. So you think about the hurricanes that we have had, and the intensity of them has been pretty massive. This is Hurricane Sandy in 2012. Climate change is contributing to an increased incidence of extreme weather because the environment in which all storms form has changed from human activities. This is Kevin Trenberth of the U.S. Center for Atmospheric Research. So this is not me saying this. This is a man who deals with the climate, and has, I'm assuming, for his career. So, and again, says from human activities. Again, this is talking about the thing that I was speaking of as far as marine ice sheets and the ocean. And I'll look at what they have for notes, but this is one of those things that I think is pretty important that people understand and is a huge thing now for us. So it says, this video is going to show you, this is video. I didn't know that. Sorry, we'll see if it'll play. I don't know if it'll play. I don't think it's going to play. So what it says is the video is about the impact of melting ice on sea level rise. So what I was talking to you about, and I'll just explain it. So like if this ice is floating, right? So if you have ice floating in a drink, that ice melts. It doesn't actually rise the level of the water or alcohol in your vessel that you're holding. So this ice melting won't necessarily raise this level. What it will do is allow this ice to do what? Slide into the ocean. Does that make sense, everybody? And then that becomes a problem. Because with this ice melting, then this ice will start to melt. And then with this ice melting, then this ice starts to melt. And then all of it starts to slide. So, I mean, they've already shown that this is what's happening in Greenland, what's happening in Patagonia, what's happening in Antarctica, and in the Arctic as well. So even the barren ice sheets are moving into the ocean at a faster rate. So cleaving, when they show those giant pieces cleave off, that's this too.
Scott,
So, yeah.
on your computer above the slides it says editing view,
Yeah,
or right there. What does it say
Okay.
right beside it?
reading view.
Now,
I think he did it. I think
and
that's what I
now
did before.
now-
No, I think that's it. I really do. I did it before and I didn't remember what I did. I'm pretty sure that's it. So the next one is jar. Excellent. Thank you. Good job, right? It says top 10 cities at risk of sea level rise in 2070. So I don't know if I'll be alive in 2070. I don't have a clue. But what I do know is Ayla will be, other children of our children or children of us or whoever. The thing so I just did this accidental tour of like Native American stuff out west, and I'll tell you about it later if you want to hear it. But my point is that a lot of those people talked about 7 generations, right? They would talk about thinking 7 generations into the future. That's not something that the average American does on an average basis or a normal basis. But I think that's an unfortunate thing. So this is talking about in the fairly in the fairly not too distant future. That's a weird term, I guess, but not too far down the road. The top 10 cities at risk of sea level rise in 2070. So Miami. This is a giant city in China. New York and Newark, New Jersey. I don't know where this is. Shanghai, I do know. Mumbai is again, incredibly poor and is in Southeast Asia in India. I know that this is in China, that's all I know. Tokyo, Japan, Hong Kong, huge, Bangkok, huge. So the populations of these cities are enormous. This is the estimated exposed assets. In other words, the amount of money in trillions of US dollars of what that will mean. So it makes our debt, this is close, this one, just one city. But that's phenomenal, right? And that's economic. Who pays for that? Right? So these things become incredibly important issues for all of us, not just for Republicans or Democrats or United States citizens or Indian citizens. It isn't a partisan issue. This is Tucson, Arizona. Arizona's obviously has been in the news quite a bit lately, and I think this is a video too that's not going to play for me. Because of my issues. But it says this time-lapse video of a strong thunderstorm produced torrential downpours and downburst winds in Tucson in 2015. So it says while that particular event cannot be directly linked to climate change, it does help to make a point about how Earth's climate system is changing. So, and I wish that I don't think that it's gonna work. This is Duluth, Minnesota. So I was recently in Duluth with Kelly this summer. I didn't even know about this when we were there. But this was because of an extreme rain event in Duluth in 2012. What happened in Duluth this year? Another extreme rain event. So Duluth, Superior, and that whole area were flooded again this year. This happened because there was so much water running underneath that blacktop that it just washed all of the rock underneath it and it just all buckled.
I saw that, that was
Did you?
unbelievable. I
Yeah.
didn't even walk down that street, that was uphill from where I was at. And like, parts of the residential part of Duluth is like 600, 800 feet
Yeah.
above the lake.
Yep.
And you had these huge washouts and sinkholes and everything forming. It didn't matter, you know, the water came right off the bluff, so if you were in a low-lying area, you were actually better off than you were if you're on the hillside.
Yeah.
You know,
And I know one of the women that was presenting at the event that I was at had walked down the street too. So you know, again, amazing weather events. This has changed in total snowfall in the 48 contiguous United States and from 1930 to 2007. So, and this is, you know, less than 1.2 feet a change of, and this is, you know, this is 1.2 feet greater. So, or sorry, percent. This is percent. So less snowfall in red versus more snowfall in blue. So again, it's different greatly. So like if you look at the Northwest, they've had way less, and they used to be known for a lot of it. And then even out here in New York, so if you know about, you know, Buffalo and the Lake Effect snow, that's changed a lot. They've had more, but not great. But then you get down here in the south, so this is, you know, in North Carolina. So they've had way less snow. But you don't even think of them as having snow really. But it's changed their climate has changed. And again down here, so and the number of hot days has changed too. And this is soil moisture. So if you're a farmer, this is something that's important to you. In 2095, it says compared to 20th century average. So if you're a farmer, this would concern you. This is the Hudson Bay. So this is lower and higher. So like higher temperatures up here, but lower temperatures where in the grain belt, right? Moisture, is that what I say? Temperature? Yeah, sorry. So if you look at lower moisture levels in the grain belt, what does that mean? Potentially. Yeah, so the need for more water. And this is the Colorado River Valley right here. It's incredibly dry, right? And they already battle over water. You know, this is 2016, 2 years ago in California. What's happening there now? You know, we've actually traveled to the Redding area. I know other people have too. It's phenomenal. It says for every 1 degree Celsius of warming, lightning strikes increase 10 to 12%. So that's just one more factor involved. So that increases forest fires. It also increases other dangers. Worldwide extreme weather catastrophes. So these are the orange is extreme temperature, droughts, fires, blues, floods and mudslides, and green storms. So again, the general trend line isn't extreme in this one, but it's still up. Like if you know, when you see it, it's up. And this is, you know, from 1980 to 2016. Yep, right. Right. Okay. This says systems vulnerable to climate disruptions and things that may lead to political or social instability. So food supply, you think about that right now, food supply stuff. You know, there are countries and not, you know, not that far away from us really, and countries that depend on us for food, water. And then global health, the reason, do you guys understand why they show a mosquito? What disease causes more death in the African continent than any other? It's also why most actual original African cities were built above the frost line, or well, not the frost line. I'm sorry, the line where most of the mosquitoes would not go. I can't remember what it's called right now, but like some of the most populated cities were built up farther away from water and farther away from in areas that would get cold enough to kill off mosquitoes, and now they're not. The warmth is reaching higher and higher. So the one I'm thinking of is Nairobi. Yep.
That even might die to see me have to speak.
Yeah, I can speak about it. So some of this stuff is health related, and some of it is is going to impact us because it's on here. So is the fact that water, like I said, South Sudan being the newest country on the planet, is literally they have no water. So that's a big deal, and we'll continue to do it. So this says, as temperatures rise, so does water use in the United States as well. So when you look at crops, people, energy, industry, animals, all these things use water and need water, and still do. And that's the United States, where we generally have enough or can figure out a way to get enough. Bottled water is one of those interesting things that exists mainly in obviously affluent countries. Things like life straws, allowing for people to drill wells in Africa. That's a huge thing. So then, moving on, it says pregnant women and Zika. So again, mosquito-borne stuff or bug-borne stuff. So ticks around here. Why are there more ticks? What kills a tick, or what causes a tick to go dormant? Cold weather, right? So the fewer cold weather days, the more ticks you have. So those things happen more and more and more. This is the CDC. Again, I try to stick with what I believe is science. The CDC is science, in my opinion. Again, this is ticks. So the Lyme disease cases on the rise. That's 97 in 2013. I have Lyme disease. My son had Lyme disease. My dad has Lyme disease. So, that's a reality around here, and it's on the rise. Allergies on the rise. So grains of pollen per cubic meter have increased, and that's showing from 2000 to 2040. So that's pollen per cubic meter. I don't really know what that means. I just know that's a larger number. And if you have allergies, then you might want to care about that. I don't have. Oops, sorry. So this is impact of climate change on human health. Again, there's a lot of stuff there, but the things it says, severe weather, right? Air pollution, changes in vector ecology. So the vector ecology is all that disease stuff. Malaria, Zika, all those things that carry diseases and cause diseases. So West Nile, but other things as well. Respiratory allergies, that increased allergen thing. Water quality impacts. So cholera, dysentery, two incredibly awful diseases. I still cannot imagine dying from having diarrhea. But people do, and literally many, many, many people in developing countries do. And that still blows my mind. Malnutrition, diarrheal disease, again, water stuff. Environmental degradation stuff, so forced migration, civil conflicts, mental health impacts. Some of this stuff is happening now again. Extreme heat, health-related illnesses, death, cardiovascular failure. That stuff's happening. Again, it also happens to increase the amount of fires, which that stuff has been awful this summer. Like Greece, over 80 people died in Greece from fires. Greece is not considered a developing country. They just couldn't get away. And we've had them in the United States. Is anyone who thinks that the topic of climate change, I have to read this slowly, is a partisan issue is not focused on the reality which we as public officials and citizens are dealing with. This is a crisis that grows day by day. Again, this is a Republican mayor of Miami, in 2016. So, not a partisan issue. What do we need to know and do to move forward? So, anybody need to leave yet? Is it getting too late? Are you all good? Am I doing this at a fast enough pace for real? Okay. So, EPA chief, Scott Pruitt says carbon dioxide is not a primary contributor to global warming. However, I don't know. So it says no that despite the fact that there are obstacles in our way, such as our current EPA chief, the Idaho legislators signed off on school science standards that leave out climate change. They're adopting to leave out climate change in science. And why scientists disagree about global warming? That report is not science. It's literally not science. Again, I can show you many sites that are science and are scientists and are science-based journals that are peer-reviewed that do not disagree on climate change.
We should tell them too that go back to the.
Oh, yeah,
last
okay.
slide.
Yes. This one?
So, we are both teachers. And
Yes.
every, I don't know, how
Year.
many teachers in Iowa at least.
And every year
get
I
a
get it.
copy of
Yes.
this.
So I have numerous copies of that CD.
Yeah.
Yes,
Really?
DVD, sorry.
And
About why scientists
And
disagree.
I think I actually got 2 of them.
Probably, I get them
And
every
then
year.
another science teacher at the middle school got one, and these are nice, thick books that
Yes,
went
yeah,
out
and the
to,
book. That's right.
thousands at least of teachers.
Yeah.
So that's pretty.
And I actually looked up who was behind this, and I can't remember
It
now.
was it was something intergovernmental, I don't know.
Yeah. It's
It's
So was that
Exxon.
in the last year that you?
Exxon started that in 1800s.
Yeah.
They did
Probably.
a study to find out if fossil fuels was going to increase the atmospheric problems. And they said, find out, yes, it did.
Yeah.
Well, they thought to themselves, we still want to sell oil. So they came up with the deniers. And then they brought all the Republicans.
Yeah, and I know this is like from basically a giant super PAC, essentially, a giant bunch of money. But I don't remember the exact name of it. It's an organization, a politically, or sorry, group of not pollsters, people that try to influence the government.
Lobbyists.
Lobbyists, thank you.
The Koch brothers.
Yes, could be. So this says, this is talking about public will. And this is the part that, again, gives me some hope. It says more than 7 in 10 favor a 50% clean energy goal. So in other words, at least cleaning up the environment, right? Some people in Minnesota have proposed requiring that the state get 50% of its electricity from renewable sources with wind, or like wind and solar. Does that sound like something that you would favor or oppose? So when they asked that question, strongly favor, 43% of them strongly favored it, and somewhat favored 28%. Somewhat opposed and strongly opposed, there were a total of 27%. This is in Minnesota, but this kind of shows that the public is willing to move or desires to move toward this. Again, hopeful. That's the public. This is Maryland. Marylanders want renewable energy. So this one, I'll try and, I guess it might not let me. Let me see if I can do it. It won't let me. But it says Maryland, I can't do this.
People in
People from Maryland want renewable energy. 76% of them are in favor of solar, and 69% in favor of wind energy. So that's a very positive thing. It says most people from Maryland don't know that coal is their largest source of electricity. So like they didn't even know, right? So kind of a misconception. And that's important to clear up. And then the reality there, it says 44% of their energy was coming from coal, and nuclear 40%. No, sorry. Yeah, 40%, 44%. That doesn't look right on the graph, but that's what it says. So then it says they want to buy renewable energy. 54% of them want to start to buy renewable energy. I was in Maryland last year. Maryland is incredibly poor, except for on the coast. and in a couple of cities. Like they are really poor. And the paper mills are all gone, so like there's a lot of poverty. So if 54% of those people are voting for renewable energy, that says something too. Somebody has to go somewhere to go on. It says more than 6 in 10 Trump voters support taxing and or regulating the pollution that causes global warming. So 6 in 10 Trump voters, 60%, support doing something about the stuff that causes global warming. Moving on. American state schools should teach children about the causes, consequences, and potential solutions to global warming. So again, they strongly agree, 38%, some agree, 38%. That's roughly 76%, if my math's correct. That's a pretty high percentage. And this comes, I'm trying to see where this actually, like, this is Center for Climate Change. That's who put this out. And Yale, George Mason and Yale. So, you know, I can't speak to exactly who they talk to, but this one says there are solutions to implement. Be water wise. Again, some basic stuff. Reducing waste, saving energy, green travel options or opportunities, increasing them, clean energy, the small changes that it lists here, plant a tree. Their carbon sinks. So they take carbon and use it and then put it into the ground on the whole. So just that stuff. It says spread the word, share what you know. Why? Because the more people that speak about this, the more the people who are supposed to be working for us in wherever it is, Madison, Des Moines, Elkader, or Washington, D.C. Those people are technically, basically are representatives. They're supposedly supposed to be representing us, but they're also our employees to a certain extent. And essentially are supposed to be doing what we tell them, right? Not whatever they are told by others who have more money than we do. So countries are taking the lead. Also states and communities. The Paris Climate Agreement, its key points. Temperatures, the stuff that I talked about. So if you don't know anything about this Paris Climate Agreement or Paris Climate Accord, we didn't sign it. And we were, at this point, the only country, I believe, there might be one more. Historic Pact approved by 195 countries will take effect in 2020. It's about reducing temperatures. It is not an incredibly powerful agreement, but it's something. So it says keep warming well below 2 degrees Celsius. Again, what I say, we're at 1 degree already. This is only below 2 degrees Celsius. It doesn't seem that phenomenal, but 2 degrees Celsius warming, they're talking that could be 5-foot sea level rise. That's a big deal if you live in Miami. So important stuff, the financing of it. Rich countries got to provide most of the money. The differentiation. Developed countries must continue to take the lead. We are a developed country. So I didn't ask this at the beginning, but why should the United States care about this? Why should the United States care about this? Technically, we don't anymore. China just passed us.
Because
But
our
we
children and grandchildren and great-grandchildren and so on will never see life like we have it now.
They won't. If this, yes.
I think when you're
that,
talking climate change, it's worldwide. It's not, what happens in China affects us.
Yes.
and people are gonna migrate because it's gonna make a lot of other places I can't say that. Uninhabitable. But like I think that if you want to preserve what we have here, in more ways than one, it's going to be overly populated very soon if we don't keep other places habitable.
So can I add something as an armchair ethnographer or cultural ethnographer or whatever you want to call me? So what happens if more and more people are in conflict over water, over resources, more war? So then what happens with our leaders? What do they do with those people more and more? Demonize them, put them into different categories, right? Isolate, become more nationalistic. It seems to me that we are headed down that road already. It seems to me. So that stuff scares me too. So when I see that stuff happening, when we're moving away from the rest of the country, pushing the rest of the country away, and demonizing certain individuals, then that scares me. And how is that not going to happen more if we don't take this stuff on? So I guess that would be another question I would have. So then, again, burden sharing, right? And the idea that you have to review this. You have to have a group of individuals or a group of countries to review this. And it says each review will inform countries in updating and enhancing their pledges. And then it says vulnerable countries have one recognition of the need of averting and minimizing and addressing the losses suffered due to climate change. That's past tense. It's past tense. Why is it past tense? I'm sorry, I treat you like the students in my classroom, but why is that in past tense? Has this already happened? Yes. That's the answer to that question. I'm not going to leave you hanging because you don't seem to be too participatory. So you've done a good job. So do you understand what I'm saying? It's already happening, right? So Tuvalu, a little tiny island nation, they're literally having to desert their country. It's a smaller country, but it's in the Maldives. Their country's going literally underwater. They don't have a country anymore. So it's already happening. So these things are already happening and having to be mitigated and reconciled, if that makes sense. So people are having to take, actions to try to help these people out. It says this, businesses are taking the lead. If you think about this, insurance companies, would home insurance companies have an interest in this? I would if I were to have this insurance company. It says American businesses are taking big steps to combat climate change. 81 companies with more than 9 million employees in all 50 states are making at least $160 billion in low carbon investments. So there's all kinds of different companies involved in this, but that's pretty cool to see. This is cities taking the lead. So I don't even want to try to zoom in on this, but you can kind of see Europe big time, the United States big time. Wow, didn't know that, huh? We're talking Rio, this is South America, this is Paraguay, Uruguay, South Africa, West Africa. Not a lot happening in Saudi Arabia, just saying. This is India, couldn't help it. Australia, sorry. So Tokyo, Japan. So pretty interesting to see that. So these are people leading the way. Educators. This isn't the one that I went to. I don't see my face in there. But is this you, Don? Are you in that bunch? I don't see him there. That looks like the school, I bet. And it says, and taking action is getting easier. So this wind and solar prices in lower income countries. So it says solar PVC electricity is now cheaper to produce than wind electricity in many emerging markets. So solar, and I'll speak to solar really quick, but is even becoming less expensive than wind. And that's over, does it say how many years? 2010, I don't see the total number of years. But that has happened without subsidies now. Like that is happening still even without subsidies. So pretty amazing. And I'll talk a little bit about it in a minute. Then it says the LED cost down curve. So LED lights in US dollars, so has come down I don't see the number of years there, unfortunately, but I'm assuming that's at least every couple of years. Now LED lights are not too bad, and they use so much less. So this is an example of it looks like a Central African home with the solar panel on it. So because I decided to, I've had a lot of involvement for my classroom with other countries, and some of those countries have been in Africa. And those people have cell phones, and they're able to do so much with a cell phone, or even just a laptop in a school. And they do it with solar panels. And this one is talking about the cumulative global investment in commercial building energy efficiency, the retrofitting of it. So will total $959 billion from 2014 to 2023. So to try and deal with the fact that our climate is warming. So businesses have an interest in this, definitely. What actions will you take? So, again, what actions can you take to try and affect this? So that's the end. And I'm definitely willing to take questions or to talk more about this, or to show you some of the other sites out there that have more information on them. One that, if I can, I'm sorry that this is what my computer always looks like. But one of them I'll show you quick is this. This is emissions by country right now. And this interested me because this is 2017 data. And this, again, this is important to me. This comes from the EPA. Still, in 2017, this would be hard to find on their site, but I Googled the actual question. I didn't look through the EPA. If you look through the EPA currently, climate change is not listed there at all. So you can't find it. But you can find the data still. So the EPA is still doing the work that they've been doing. It's just that it's been kind of buried. But this is kind of interesting to me. So you look at this by country. This is the United States. We're at 50% now. We're about half of what China is putting out. But here's one of those questions that I've asked, and I've asked my students this numerous times. So right now, this is a reality. The CAFE standards in China, which means the standards that cars have to have as far as emissions and miles per gallon, are higher in China than they are in the United States. So we can't sell our cars right off of our lines in China. The other part of that, though, is when you look at this, is it not okay for the Chinese all to have a car? Can we say that with good conscience? We sure have a lot of them, right? So that's one of those things that I think is like a global conversation that needs to happen. Or even a Clayton County conversation, or a Crawford County conversation, or a Midwestern conversation, or a conversation at least. Like, do we all need to have a vehicle? And do they all need to have a V8 and pipes out the top? That's where I live. You know what I mean?
More on the road. Just my own 2 cents. I know I bike. I do a lot of biking. Everybody has these big, huge pickups and SUVs. I don't care how fuel efficient you make them. When I see them leaving a big block long plume of diesel smoke, they're polluting as far as I'm concerned. Especially when you're blowing off the road and I'm biking. We have, there's a lot of room for improvements. As far as fuel efficiency, we have a long ways to go over here. And again, that gets into political issues. People want to work for a living. They want employment. They want to make decent wages. The auto industry provides a lot of jobs. But at the same token, if you have a car, you have to consider, well, what goes into that car. You have to open up or mine taconite and iron ore from up north. You get the iron and build that car. You mine frac sand and inject it underground so you can pump out oil to get the gasoline that powers that vehicle or diesel fuel. And plus you have to have road infrastructure, so you're pouring out roads, making bridges, stuff like this. Okay, you're creating jobs. It's bolstering the economy. There's no doubt about that. It's called capitalism. But at the same token, if you have runaway capitalism, which I think we have right now globally, it's uncontrolled. That's what's creating it indirectly leads to social issues, political issues, certainly environmental issues, and water quality, opening new mines, even population growth. Everything you see on the news is about cities wanting to expand outward and keep on growing. And that again, that's the capitalistic system, which depends on growth. But when you have that kind of growth, you are exploiting not only the environment plus biota, and you're creating pollution in the process. So yeah, as far as like every China person having a car like we do, yeah, it's going to have its own set of problems with it. And over here, just my personal experience speaking, people want to duck their head in the sand. They don't want to hear about it. You know, I'm sorry to say, but these are issues that go along with climate change. It goes round robin. These have to all be addressed in order to solve the problem of climate change.
Yes,
And
yes.
I said it.
Certainly. No, yes, and I agree. So I mean, I agree, but I think that ultimately it comes back to honestly to the dining room table. It really does, because capitalism, like you said, Phil, capitalism is the system we live under. It's the system that essentially China lives under. It's definitely the system that Russia lives under. It's the system that the EU lives under. It's the system even that Canada land lives under, or the Canadians. So, so like it dominates even Africa. So, you know, it is made to consume. Yes. But we are the consumers. We all are. I am one. So, you know, it takes us to change that. So we still vote with the dollar, right? We still vote with our actual votes too. So that's all important. And then I think that the things that we do, you know, when you look at this, the people that will be most affected live in this area right now. The most immediately affected, Southeast Asia. And they are definitely the smallest imprint, but they're also a billion people. So, yes.
One of my thoughts looking at that graph is the 30% from China. We buy so many goods from there that the United States significantly contributes to that number.
Exactly.
So I just want to bring that up. And then on a different vein, I know our local electric co-op, you can pay $3 extra a month, and then that helps fund new green sources of energy. And they only had to do that, only so many people can be on it at a time. You know, I'm thinking after listening tonight, you know, maybe I'll just send them a note and say, hey, if you make more of those available, I'll buy more of them. Because it gives the co-ops a way to get a little bit of money to start investing more in wind and solar energy. I know one of the things that we started to do at home is, you know, your lawnmower every hour you run is equivalent to driving 100 miles. So we kind of made a conscious decision to mow less. And, you know, but it's a small thing, but if everybody did that,
yeah, there was I read a big thing on this on the news just a couple of days ago. You know, they're trying to get people to get away from mowing lawns and have more things like you just had little furry.
Natural birds will nest in the area and like butterflies. So like kind of equal that. Also, there's a whole bunch of those graphs that were in the presentation, some that weren't. If you want to look at statistics. Yes, I did.
You guys done or do you have more questions? I'm being talking about this. So this is NASA. I like to point out science, right? So this is NASA's site. The June 2018 has the third warmest June on record. So, you know, that's just you. So they have tons of data at NASA. I can show you 350.org. Climate. This is climatecentral.org. They're also really good. They have a lot of good stuff there. Yeah, I'm wrapped up.
Just come mingle, talk to them.
I'm done.
All right, let's give Scott a round of applause. Thank you. We also have, we'll pass around, you can sign up. Scott said you could send out more information or some of the resources that he has available.
And I'll share it like a Google Doc with you guys if you want.
Just name and
Stuff on it. Oh, and I never really passed these around. I forgot to mention it. But the graphs that I was showing up there are here, and little sections of them to look at. Yeah.
I got you, Dad.
What's that?
I got it.
You did pass it out?
Well, yeah.
Some of them are pretty interesting. The change in latitude of bird center of abundance. That one's important. So how much it's going up north farther. Well, honestly,
that was important information.
I don't know why. But I've looked at it. Oh my God.
She's connected.
Yeah.
Scott, did you stop this?
I don't know, I might see.
Yeah. Right. Sure. Yeah. Yes. Yes. It was a good turnout. Yeah.